Good morning all. I Salim, Assistant Professor in Kite Group of Institutions, presenting you static and dynamic characteristics of an instrument. As its name indicates, static characteristics are those which are not changing with time, and dynamic characteristics of an instruments which are changes as the time goes. So static characteristics of an instrument are considered for instruments which are used to measure an unvarying process conditions. The performance criteria based upon static relations represents the static characteristics. The static characteristics are the value or performance given after steady state conditions has reached. Dynamic characteristics of an instrument are considered for instruments which are used to measure a varying process condition. Performance criteria based upon dynamic relations represents the dynamic characteristics. So here are the terms included under static characteristics. First, accuracy, precision, bias, sensitivity, linearity, resolution, hysteresis, dead zone, backlash, threshold, input impedance, loading effect, repeatability, reproducibility, and static error. Here are the definitions. Accuracy is defined as the degree of closeness with which an instrument reading approaches to the true value of the quantity being measured. Precision is the degree of repeatability of a series of measurements. Bias is a quantitative term describing the difference between the average of measured reading made on the same instrument and its true value. Then sensitivity. Sensitivity is defined as the ratio of change in output signal to the change in input signal. It is the relationship indicating how much output changes when input changes. Then the term linearity. Linearity is the best characteristic of an instrument or a measurement system. Linearity of the instrument refers to the output is linear or directly proportional to the input over the entire range of the instrument. So the degree of linear relationship between the output to the input is called linearity of an instrument. Then resolution is the smallest change in the input value that required to cause an appreciable change in the output. Then we have dead zone. Dead zone or dead band is defined as largest change of input quantity for which there is no output in the instrument due to the factors such as friction, backlash, hysteresis within the system. Okay. Dead time is the time required by the instrument to begin to respond the change in input quantity. Then we have hysteresis. Hysteresis is known coincidence of loading and unloading curve on output. Hysteresis effect shows up in any physical, chemical or electrical phenomena. When input increases, output also increases, and calibration curve can be drawn. If the input decreases from maximum value and output also decreases but does not follow the same curve when there is a residual output when input is 0. This phenomena is called hysteresis. The difference between increasing change and decreasing change of the output value is known as hysteresis error. Then our next term is backlash. The maximum distance through which one part of the instrument is moved without disturbing the other part is called backlash. Backlash may be defined as the maximum distance or angle through which any part of the instrument can be moved without causing any motion of the next part of the system. Then we have reproducibility. Reproducibility is defined as the ability of an instrument to produce the same output for repeated applications of same input value under different environmental conditions. In case of perfect reproducibility, the instrument satisfies no drift conditions. Then threshold, it is the minimum value of the input which is necessary to activate an instrument to produce an output is termed as threshold. Then input impedance, the magnitude of the impedance of element connected across the signal source is called input impedance. Then we have repeatability. Repeatability is defined as the ability of an instrument to give the same output for repeated applications of same input value under same environment conditions. It is same as reproducibility. Then we have loading effect, is the incapability of the system to faithfully measure, record or control the input signal in accurate form. Means under no loading condition we have different readings, under loading condition we have different readings from the instruments for the same application measurement. Then we have drift. Drift is an undesirable change in output over a period of time that is unrelated to change in input operating conditions. Under operating conditions, drift is occurred in instruments due to internal temperature variations, aging effect and high stress, etc. Zero drift is used for the changes that occurs in output when there is zero output. It is expressed as percentage of full range output. Drift may be classified into three parts. It may be classified or differentiated into three parts. First, zero drift, span drift, zonal drift. Here is the example of zero drift. It is a parallel line to our measured value, actual value. It is called zero drift condition. Here is it is started from 0 and at the output level or at the final level there is a deviation. This difference is called span drift, and in our measurement if there is a at some part of reading at some time, at some instant of time we have different reading or non-linear reading, this is called zonal drift. Okay, then we have static error, the difference between the true value of the measuring quantity to the value shown by the measuring instrument under non-varying conditions is called static error. Static error is equal to true value minus instrument reading. It may be positive or it may be negative. Positive static error means instrument reading high and negative static error means instrument reading low. Then we have dynamic characteristics. Dynamic characteristics, the dynamic behavior of an instrument is determined by applying some standard form of known and predetermined inputs to its primary element or sensing element, then study its output. Generally, dynamic behavior is determined by applying following three types of input. First, step input, then linear input, then sinusoidal input. By using these type of input, we can study the behavior of any instrument, or we can study the dynamic behavior of any instrument. In dynamic characteristics, we have speed of response, fidelity, lag and dynamic error. So first, speed of response, it is the rapidity with which an instrument responds to changes in the measured quantity. Then fidelity, it is the degree to which an instrument indicates the changes in the measured variable without dynamic error. Faithful reproduction or fidelity of an instrument is the ability of reproducing an input significantly faithfully or truly. Then lag, it is the retardation or delay in the response of an instrument to changes in the measured variable. The measuring lags are of two types, retardation type and time delay type. Then we have dynamic error. It is the difference between the true values of a quantity changes with time and the value indicated by the instrument if no static error is assumed. It is also called the measurement error. When measurement problems are concerned with rapidly varying quantities, the dynamic relationship between the instrument's input and output are generally defined by the use of differential equations. In this case, we define dynamic error with some type of differential equation. This is all about static characteristics and dynamic characteristics of an instrument. Thank you.